So I'm going to be doing a mini lecture on 2D arrays and array lists, so you can listen to me talk and not just have to read the book. Okay? And right here, this is a nice two-dimensional array of pongos. So some examples of declaring a 2D array. We can do something like this. So you see we have our types ints, and then we have a pair of square brackets, just like with a normal array. But if you see here, we have a second pair of square brackets, right? And that's telling it we want it to be two-dimensional, right? And so this first number here, right, this was the size of the array. In this case, this specifies the number of rows. So this array is going to have 5 rows, and in each row, it's going to have 8 columns. Okay, 5 rows, 8 columns. We can also specify default values. So say I have this new array called grades. I can have 1, 2, 3, 4, 5 rows with 1, 2, 3 columns, right? 5 rows, 3 columns, kind of like a table in Excel. And here I have, my collage of pongos with 1, 2, 3 rows and 1, 2, 3 columns. And we can declare that array like this, right? Follows that same syntax. We start off with the type, 2 pairs of square brackets, name of the identifier for the variable, our assignment operator, our keyword new, saying that we're going to create something, the type, and then in these 2 pairs of square brackets, we have the number of rows followed by the number of columns, right? Row, column, that is going to be the order that we follow. So how you would access elements is kind of like a table, right? We have these rows and we have these columns. And what you would do is, instead of just having 1 pair of square brackets, you would have 2, just like when initializing it. And these specify the row and the column you want to access. So this first line is going to be row 0, column 0. You can see that value is 89.5. This one's going to be row 0, column 1. Row 0, column 1, which is 99.0. Row 1, column 0, right? And row 1, column 1. 76.5. So if you look at this, what will this value be? Right? Well, this is saying we'll go to the grades array. We'll go look at row 3, column 2. Row 3, column 2, and that is the value 90.0. Okay, just like that. It matches how we declare it, initialize it, row followed by columns. And guess what? 2D arrays are really just arrays of arrays. So I have this link in my lecture slides. If you go download my lecture slides, you can actually click on this link. It'll take you to Java Visualizer, and you can go and step through this example. But I'm just going to show you what it looks like. So say I have this same array, right, this two-dimensional array, and I create it in Java Visualizer. Well, we know a normal 1D array is like this, right? We have 1, 2, 3, 4, 5 rows. 1, 2, 3, 4, 5. And guess what? Each one of those is a reference to another array, and this array containing doubles. So grades is just an array with references to other arrays. Interesting. Yeah, so you can see here we have 5 arrays. 1, 2, 3, 4, 5. You can see the values for the first row are in this first array. The second row are in this one, etc., etc. And this big old grades, that is just an array that's pointing to each one of those individual objects. Okay? So if we did something like this, we printed out grades.length, well, what is that referring to? That's referring to just this boy right here. And so grades.length is 1, 2, 3, 4, 5 elements. There's only 5 things that grades points to. Right? That's just 5. It doesn't count any of these. It doesn't care about any of those. It's just how big this initial array of rows is. But if we did something like this, we printed out grades index 0.length. Well, what that is doing is that's saying, hey, go to grades, go to index 0, and go to the thing that that points to. So we go to grades, we go to index 0, and we go to the thing that points to. And then we do .length. So we're here, and we say .length. That gives us 1, 2, 3 elements. right? That is 3. So what if I did something like this, right? What is this? So I'm saying, hey, create a variable to hold a reference to a double array and assign to that variable the thing at grades index 3. Well, all that is grades, index 0, index 1, index 2, index 3. Hey, guess what? Index 3 of grades contains a reference to this object. And so when we do this, we're taking the reference, right? This line, this leash that's connected to the array, we're taking that and we're copying it into one student. So what's going to happen is that this reference is going to get copied and stored in one student. So one student is also going to point to this object, right? See, now grades index 3 and one student are pointing to the same object. Okay? So 2D arrays are just arrays of arrays, right? That is what I wanted to illustrate. And guess what? That has some funky implications. So what if I were to do something like this? Instead of a nice, even, row and column, a nice square or rectangle or whatever, what if I had funky shapes? Guess what? Well, first of all, grades is the same, because grades is an array that contains references to 0, 1, 2, 3, 4, right? Index 0, 1, 2, 3, 4. So 5 arrays. So grades is an array with references to 5 potential arrays. In this case, the array pointed to by 0 is, 89.5, 99.0, 100.0, this one. Right? The array pointed to by index 1 is the second one, and so forth, right? 5 arrays of different lengths that are all pointed to by this big old grades. Right? And so this means we can do some crazy things just because arrays are, 2D arrays are just arrays of arrays. So we can do something like this. Let's say grades index 0 gets assigned the value of grades index 1. Well, what's going to happen? So if we look closely, we see grades index 0 is going to get assigned the value of grades index 1. So this is going to get copied and put here, which means, boop, now grades index 0 and grades index 1 both point to the same little double array. See? Right? They point to the same place. We can do some even crazier things. We can say, hey, grades index 1, let's get rid of that. Let's replace that with a new array of doubles. We can also say, hey, grades index 2, we'll assign the value of grades index 0. Right? And what's happening here is it's just copying the references so that things in this array can point to the same little arrays out here in memory. Okay? And again, if you download my lecture slides, you can click this link and it'll let you visualize step by step and kind of get a feel for yourself. Okay, so when we want to loop over ragged arrays and 2D arrays, you will need 2 for loops. All right, one's for the rows and one for the columns. Right? It's 2-dimensional, so naturally we got to go first row, column, 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 second row, column, 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 third row, column, column, column. Right? Nested for loops. So we create one big loop for all the rows. So this will go from row 0, row 1, row 2, row 3, row 4, right? Grades that length. And then the second loop that's nested inside, that goes column 0, column 1, column 2. And then we can do something with it, right? We can print out which row we're on, which column we're on, and the value at that row and column. All right, so if you see here, why do we use grades index I, right? Why do we use the ith element here? Well, that's because I tells us which row we're on. So we're actually just saying, hey, get the length of this row and go through each item in that. Get the length of this row and go through each item of that. And this matters when we have ragged arrays. All right, ignore the titles, those are wrong. Right, so we have ragged arrays. We do something very similar. We say, hey, go through each of the rows, row 0, row 1, row 2, row 3, row 4, And for each one of those rows, right, grades index R, that's going to refer to this whole row, this whole row, this whole row, right, or this whole row, this whole row, right, this one, this one, this one, this one, this one. And then we do the same kind of thing. So we're basically saying start off at 0, and then we make a second loop. Our nested loop is saying start off at 0 and go to the length of this array. 0, 1, 2. Right? Now we go to the next row. Start at 0 and go through the length of the array. 0. Next row. Start at 0 and go through the length of this array. 0, 1. Next row. Start at 0, go through the length of this array. 0, 1, 2. And next row, start at 0, go to the length of this array, and we just get that one element. Right, again, you can click here, and it'll give you a nice visualization of all of this. All right, so when you omit the second pair of square brackets, all this is doing is it's saying, hey, give me the thing that this is pointing to, right? Either this one array by itself, this one array by itself, or this one array by itself, right? You can break it apart into steps, right? It's not magical. 2D arrays are not magical. They're just arrays of arrays. All right, so moving on, array lists. So remember the list type from Python, right? It's great. You can add things and remove things and find things. And, you know, in Java, we have arrays, but those aren't that nice. They're fixed size. We can't do special things with them. So your replacement in Java is called the ArrayList class. All right, this is a nice link. This takes you to W3 Schools, which I highly recommend. They have nice references and examples and try for yourself examples for pretty much everything that you need to know. But yeah, ArrayLists in Java, you use them like this. You can create a new ArrayList, and we say, hey, this ArrayList can contain strings. Right? This is just like creating an instance of any other class, but we have the cool little brackets, right? These little angle brackets right here. Inside here, we specify a type. And we're also creating a variable called dogs to hold a reference to that array list, right? So this specifies what type that the array list can hold, right? Just like how an array can only have one type, an array list also can only have one type. Java is very strict about type. And you can add elements to the end of that array list by saying .add, right? docs.add. Should look pretty similar to what you've done in Python. All right, so when you want to get an element, you can't actually use square brackets because array lists are not arrays. Square brackets only work with arrays. Array lists are objects. They use methods. So we have to say dogs.get, and then we pass in an index. So this will actually get you Nina. And then here, in order to get how many items are in it, we've got to have to call another method. We got to call .size, right, with the parentheses, because this is a method and it will count how many objects are actually in there and return that to us, right? So the book is super helpful, right? It's got these nice syntax boxes, which I highly recommend. They're great references, right? You can quickly look at an example of how you can make an array list and how you can use it, right? Plus some nice little comments. So some things to watch out for. Make sure that you import ArrayList at the top of your code. So you've got to do import java.util.ArrayList, just like this. If you don't, you may get an error because Java is going to be like, I can't find something called ArrayList. So we got to import it, just like we import modules in Python. ArrayLists, again, can only hold objects of one type, right? Just like arrays. It's not like Python. Even though ArrayList is nice, you can add objects and remove objects, it can still only hold objects of one type. It's all got to be the same. And that type that you specify must be a class or reference type, right? Some kind of object. Guess what? Trying to do this, trying to create an array list to hold ints, that doesn't work, right? Because int is a primitive type. So this is something that's very weird, very particular to Java. You've got to remember this, right? We can't put primitive types in these angle brackets. Instead, we got to do something like this with the capital I integer, right? If we want to have an array list that stores ints, we've got to use this capital I integer. This is called a wrapper class. So the book talks a little bit more about this. You don't need to know the super technical details, but this is a class that basically is the same as an int, but it is a class, and so Java likes it. It's a class, it's a reference type, so we can make an array list containing these. And you just treat it like an int. You can add 5 to this array list. You can, get numbers back, and there will be actual ints. Java does something called auto boxing, which pretty much makes it completely abstracted, transparent. It makes you can pretend that these are just ints. You just got to remember to write capital I integer when you're creating the array list. And then here's a nice reference. Again, my lecture slides are always posted on Canvas. Here is a comparison of what you did with lists in Python and what you can do equivalent in Java with array lists. All right. Again, let me know if you have any questions, and get the reading done, finish up the concept quiz, and we will see you again on Thursday.